Hi everyone, I'm Anish. I'm the founder of DevVoid, and here at DevVoid, every Wednesday we take one thing developers think they already understand and go all the way down. These are our internal sessions, put up unedited. So take a seat back and let's get learning. Okay, I think let's start in. So yeah, I think primarily, I hope everyone like the URL session before. Now this time I was thinking as a follow up for URLs, right? It just made sense to do something regarding routing overall, mainly DNS routing and how that works using the host name and stuff. So I think I mainly want to focus on that this time. I think this is a very chunky one, I think, compared to last session. So had to make some notes as well, just so I don't drift apart from topic too much. But I think, cool, if everyone's ready, we'll just get started then. So, I guess one thing that I would like to everyone to think about, right, is this, which is, so let's say you go to something like google.com or whatever, right? Just take any website you have gone to today, right? What is happening in the background to allow you to preview that page, right? We understood how to break down this whole https colon slash slash and whatnot, the whole format, right, last time, but like that was how to parse it and get that details from it. Now let's take only one part of the URL, which is the host name. Okay, so it's just google.com. I don't want HTTPS, I don't want anything else right now. I only care about google.com. Now, or let's take any, let's take DevVoid.org. There are some differences between. Let's add some examples first before we go further actually. So google.com, DevVoid.org, and other than that, can you give me some random websites that have like just the host names? Any just random websites that you guys use normally?
You can use something like I don't know, some .shop domains, I guess.
Mm-hmm.
Uh,
Example. Like,
um, uh, or the right deshbug.merch. I think that's a domain that they have.
what is it?
Deshbhakt.merch.
Okay, we'll take that. And then we will also take some, I'll just take staging.automotiveai because I wanted some subdomain examples as well. And then, yeah, let's take a more crazy one like AI dot. I think we have
Uh,
staging.ai.tether.ai.ca, right? That we have as well right now.
right.
So we'll take these for now. And this is enough. We don't need more than this. These are some good examples of what we have and what we play around with, right? Now, the biggest question, I guess, that I want to, if anyone knows answer, let me know. But when I give this address, right? Or rather, this is not address. This is address. Usually, this something called IP address, right? So that is the address. This is just a name. So how do you map that? How do you know google.com is equal to this address? How do you know devoid.org is this address, right? Any idea on that? How that mapping process works or what is happening actually to get that IP address from a name? Any kind of guesses also is good. So who knows it? Or where do you go to get that? Or what is happening? Right? Anything.
DNS.
Right. So DNS is correct, but any guesses on what the process looks like on that end?
Yeah, so what happens is like this Sham was right on the DNS part, but these names are basically searched, right? There's a like lookup happening
Mm-hmm.
when we search for it from the browser or somewhere, right?
Mm-hmm.
In case of a front end hit. So
Mm-hmm.
over there, first hit goes locally to the cache that the operating system holds
Mm-hmm.
for the DNS queries, right? Uh, let's say the like the what's that called? The IP address, sorry, huh? The IP address, let's say, is not found on our local cache.
Mm-hmm.
Then our router's cache is hit first, because the router has a DNS, I think,
Right.
cache as well.
That I'll
At
explain
least,
detail, but yeah, the fundamental is correct. So it
right?
goes step by
So
step, like how you mentioned. Yeah.
it goes step by step, level up to the I
Mhm.
think the CA authority. That's what it's called. I don't know the full
Mhm.
form of it. But yeah, so from OS, then router, then the CA authority. I think that's the whole thing. I might be
Mhm.
missing a few things in between after the router actually.
Mhm.
So yeah, that's how it goes. But it's just basically looking up for a name to basically a key value search for the keys generally, or this domain, and then the value is generally the IP address that we want to go to.
Right.
Because these English names are not something that computers understand, right? They need numbers,
Correct.
right?
Correct. So I think the summary of what we're going to discuss is done already, but that is exactly gist of what's happening, right? So when you get these domains, now if you want to break it down, right? Or rather, before breaking down, let's understand why DNS was even created. Like why, what is the problem in, or how was there something else before this, right? So if you go a little bit back, right, history-wise, if you see, one thing that happened was prior to DNS, how IP addresses is the address in which machines can communicate with each other, right? But IP addresses had this unique system which was managed by Stanford Research Institute. And what they did, well, right, they used to maintain this file. Okay, I think I forgot the name of the file, but they used to maintain one file that's just called as a file, some file where it'll just be written mail is equal to 192 dot whatever IP address, and that's it. It didn't even have the ability to be like www.google.com. It was just a single word ending with a dot. Now that posed problems already at one point, which was like you only have one word, which means there's not enough ability to have tons of IP addresses. So you're already restricting yourself to how much English words are possible, right? So that was one issue that they faced. Similarly, it was a full file maintaining all the IP addresses in one file. Imagine how big that file would be if it has to map like the entire internet as it is right now. There's too many things happening. It'll be way too big, right? And every time you need to go to some location, you have to download this file and then find it off. Right now, finding where to go is like in milliseconds. That's why it's so fast. Imagine if this file was the main thing right now, how slow it would have been, right? Due to these concerns, itself the DNS system was proposed, and what it is previously it was a list, right? It's just a file which has like mail, and then let's say Google was there, some IP address here, right? IP address, spelling is wrong, I know, but yeah. Next, let's say DevVoid, some IP address, and so on. But the point is, this is all it was before. A file with one space in between the name and the IP address. And that's all that was being maintained by one. It was manually maintained, not even like automatically done. It was manually maintained through someone would email like, hey, this is my IP address, please add that to the list. And Stanford Research Institute would manually add that to the list. And that's a very tedious process, right? So that was what was happening before in the beginning times. And DNS came before URLs and everything. Like DNS was a more primary or more earlier thing, and that's why there's no URL here. It's just a word, right? That's the reason. That's how old DNS are. No, sorry, that's how old IP address mappings are. Now DNS solved this problem by saying that, like, hey, why not use a tree structure instead of a list? And that is how one nice application of trees come into picture, right? So as a data structure, I'm hoping everyone has learned about trees over here. But this is a good application of trees.
Anish, you're not able to see the screen, man. It's loading, for me.
Yeah, for others as well, or
Yes, same here.
so do you want? So yeah, I think as I was saying, basically DNS was previously a list, and now it became well DNS or other the mapping was a list, and then DNS was invented, which wait, silos maybe. Okay. So yeah, so basically mapping was a list, and after that, after DNS got started, it became a tree, and that was a proposition that use a tree structure instead of a list, because tree you can map quite easily, and it's quite powerful instead of searching through an array or list. Now, how does this tree work? How does that look like, right? Let's try to get that tree for Sham was like that. Okay. Yeah, so oh gosh. Hoping that's everyone was joining. Cool. So what we'll do is we'll try to map this tree structure into or rather map these examples into the tree structure and see how the division happens and how the lookup happens. I'll just go to Excalibur so it's a little bit easier. And something else. And what I'll do is I'll just copy these and put them right here. Okay, it's fine. I'll just type them. So we have google.com. Then we'll take DevVoid.org. I'll remove this because it's the same kind of structure. So but I'll remove that for now. And I'll put staging.automotiveai.ca because it's a subdomain structure that I want to explain. And then it comes AI. I think let's take staging. We'll take AI. AI.ai. No, I think I want one more level. So I'll go with staging here. Cool. So we'll take for these three and how they come across in the tree structure. That is the DNS. So what it does is first level called as a root. Okay. It's just a dot. Okay. So natively, every one of these domains get placed with a dot at the end. Okay. You don't have to type that in the browser, but that's what's happening. A dot comes at the end, okay, which is a root level, and you read it from right to left. Okay, so let's take google.com and break it down. And if I take it down, the first part is the dot. That is done. Okay, next comes till the next dot, which is com. So com will come right here, right, just connected like this. Okay, and then comes Google after the next part, after the comma, right? And that essentially is the, that essentially is the tree structure made from google.com. Now let's take DevVoid.org. Org means top level becomes org here. Then comes DevVoid. So DevVoid right here. Then now if we take staging.automotiveai.ca, again we go from right to left. So CA is what I'll do first. And then comes automotive AI. And then comes staging. Similarly, I think just to make our life easier, let's use the other one as well. Tether AI. Then AI. And finally, again, staging module. Right. So this will be how the mapping looks like, or the tree structure looks like. So this is what was a proposed tree structure, or rather the data structure, how it represents, compared to how it used to be, which was just an array that had the full word at the top. Now I think this is a root level thing, right? After that comes something that some of you might have heard is called as a TLD, or a top level domain. So here is the top level domain. After that usually comes the part that's directly given as a domain in most of these providers, and that's actually called as the second level domain. And everything below that is usually called as the subdomains. So this is the I guess hierarchy and structure that was proposed in the DNS aspects. One more I guess naming convention to remember is that each one of these, like Google, Com, DevVoid, org, staging, automotive, every one of those words are also called as labels. This also is just label. Yeah, that's all. Then I think, let me see if I missed anything. Okay. Oh yeah. So I added this dot at the end, right? When you add a dot at the end, it becomes something called an FQDN, which stands for fully qualified domain name. That's all. It just says that this is the actual domain name, end to end, like the full path kind of thing. How you have in your folders, right? You can have the relative path and absolute path and all of those things. It's kind of similar to that. You can think of it. Essentially, fully qualified domain. There's just some terminologies to understand. I don't think this is something you need to memorize or whatever, but I'm just telling for understanding sakes. Right, then let me see what else is there. Oh yeah, one more theoretical aspect here is that there is a restriction on what this depth of this tree looks like. I think it's somewhere around 127, I think, or 125, something like that. But the point is, this depth of this tree can only be 125 levels. There's a bigger restriction, which is the size of this host name. The size can only be, I believe, 255 bytes, and each label, which is every word, can at max be like 63 bytes. So those are other restrictions that are there when you do domain names. Again, most of the times when we write names, we never reach those edge cases or cases where it hits that boundary. But good thing to keep in mind that it's not infinite. There's still an actual limit on what the spaces look like. Now, what we'll do is, let's quickly check something up to understand a bit more about what a DNS record is, okay? So what I'll do is, I'll go dig and do DevVoid.org. I'll tell you what dig is in probably a separate session because that has a lot of aspects to it. But I'll do this command. And this gives me, ignore everything for now and just focus on this aspect, okay? The answer section. Right. Oh wait, I think that I'm not sharing. Let me just quickly share that. Oh. Share screen, that's not easy. Share and pause screen. Right. Now you can see that. Cool. So basically, I think you can see this, right? I just ran this command dig DevVoid.org. Dig is natively present in both Linux and Mac, but is not natively present in Windows. So you have to probably install it and set it up if you want to try it out. But this is what the command looks like. And this is the part that we care about. That is the answer section. Okay. What happens in the answer section? It's telling us a lot of things here. First, if you see, there's a FQDN, which is a fully qualified domain name here. Second is the TTL. There's a lot of caching involved, as Puneet already mentioned some aspects of the caching behavior. And that's what this TTL is for, to see the caching behavior. For example, if I do it now, it could count down or it might not, because there's a reason. I'll come back to that later. But now if you see, there's some countdown happening. It's 889, not 600. Right? And do once more. This is another, whenever it comes to next on something else, it's okay. You saw 889, that one became 879 because at this point in time, 10 seconds has passed. But there's some other things happening here. There's a reason for that, because this is regarding horizontal scaling and all of that, but we'll not come into that right now. But point is, this is TTL. Okay. This is FQDN, so the domain name itself that we try to hit. This is the cache time, so that, for this long, in the cache, it will be there, so that you can actually access it more easily without waiting for the full routing to happen. The next aspect of it is something called the class. We don't need to dive deep into class, but IN stands for internet, and most of the time it's going to be IN itself. So that's the reason I don't want to deep dive into it, because there's no use case in our scenario where we need to know more than that. We will dig deeper into it again in the dig session, I would say, but not in the DNS session. Now, A is one of the types of addresses, or sorry, A stands for address and is actually a type over here. So what is it? The domain name or FQDN, then comes the TTL, then comes the class, then comes the type, and finally the IP address or the value. Why is it the IP address? Because the type is A, and if it is A, it says, hey, I'm an address in the value. That's the reason you put value as address. If it is not A, then you don't put A, address over here. Very important. We have a lot of different types to discuss here. Again, I want to keep that into a separate session because every one of those records have a crazy amount of significance and meaning to it. But as you can see, for the most part, A is what we care about at this point in time. Two other things that might be relevant while trying some examples out are name server. Oh yeah, before I go to name servers, few things that I want to bring out, right, is right now, so DNS record, what is a DNS record? We learned that it is about the name, then next part is the TTL, after that we have the class, and then we have the type, and then the value, right? Now, the other part that I want to, mention regarding types that is kind of important and might be relevant for our session today, if in those examples we see these, but A is for address. We understood that, which means the value will be an IP address, usually IPv4, but it can be IPv6 as well. Now, NS is something called name server. Okay. One side. Right. Name server represents basically there's something called zone, which will come into right after this, but the names of all servers responsible for a zone. Okay. That is the main job of the name server. It holds the names of all the servers responsible for a zone. We'll understand what a zone is right after this because these are just some quick definitions before we head into that. I think this is probably what Puneet was trying to say with the authority aspect, which is this is something called SOA, the start of authority. And here basically is the start of a zone, right? This is also very important in the routing decisions that happens, and it's very it's the beginning or almost the end where you can get the actual IP address and the routing to occur, and that's why it comes at the end almost. So it follows this path, right? So SOA is the general terminology, and it's called a start of authority, and there's only one per zone, okay? And its job is to essentially mark where a zone begins. I'm going to show something about name server and start of authority, theoretically. But what is a zone, right? We didn't understand what a zone is, but we have two things that are actually talking about zones over here. Now, let's understand that. So zone is something, actually I'll go to diagram, it's probably more easier that way. So first of all, there's a domain and there's a zone, okay? In this nomenclature over here, a lot of people do use this interchangeably, but it is not. And the thing about it is a domain is, well, let's just take, for example, google.com and everything under it, that's a domain. Simple as that. There's no subdivisions, there's no other divisions. It's just google.com and everything under it is just the domain. Okay. DevVoid.org and everything under it is a domain. automotiveai.ca is a domain and everything under it. tetherai.ca and everything under it. Right. Once I'll just drink water quickly. Right. Now for a zone, the way you can imagine it is, let's keep it simple and say there's only one name server, okay? To understand zones a bit easier. Now, the purpose of a zone, right, is essentially it's a set of records, okay? Or actually, sorry, the easiest way is have you guys gone to GoDaddy or Namecheap or whatever domain providers and looked at these records that are there, like a record and whatnot? Have you seen those records?
Yes.
Yeah.
Right. That literally is kind of like the zone. That's the best way to visualize the zone. It is the list of records that governs your domain. So, for example, DevVoid.org, I can have, when I have something like, let's say, staging.devoid.org, what I'm actually doing, there's probably a railway server or some server, it doesn't matter. We use railway, so I'm just railway server example, staging.devoid.org, and we probably have these things pointing towards this. How does pointing work? A record. This is what it said is called as address record. And then we put the IP address point next to it, right, as the value. these set of values, a record, text records, there's multiple types of records that we use in like a domain provider or whatever, that literally quantifies what a zone is. It holds records that points to the right places. Right. Now we can also point to other places. That's very important to understand. Like a zone doesn't have to be fully encompassing everything within a domain. For example, I can have zone whose purpose is everything under DevVoid.org. That's always there. But I can have one more zone under that whose records showcase everything within staging.automotiveai.ca. Zone A, zone B, let's call it as. Okay. In which case, how do they point to each other? Right. This thing says when I have staging, I don't have the data, but this guy has the data. So zone A will be the source of truth, but zone B is where it gets redirected to for getting more details about it. But that's just some things that are possible, basically creating subsets out of these trees and whatnot to make division and management more easier. Again, these are extremely internal details that we can go deeper into if people are interested in that. But I just want people to understand what zones are at a very high level. Now, right, so zones are done. What I'll do is servers. Okay. We talked about how these things point to servers and whatnot, right? Now, I would not call it as server. I would call it as more of resolution and whatever. But there's three kinds of like resolvers. Okay. One is something called as a stub resolver. Okay. There's something called a recursive resolver as well. Another thing is authoritative server. Okay. The stub resolver is, for example, I ask one question and I want an answer. It is not my. So this server is somewhere where I can ask one question, right? I'll ask one question. For example, I'll ask DevVoid.org. Okay. It will only tell whether it has or not. Simple as that. Simple reply. Right. Its job is not to find it, basically. It's just to give a reply to one question. That's it. A recursive resolver is a server where I ask one question. Its job is to go and keep traversing that whole tree structure we discussed until it finds where we want to go. Right. Its job is to make sure that we can find our request, not just to reply with a simple reply. So it's actually going to give us a proper answer, even if it doesn't have it in its data right now. That's the whole purpose of recursive. This is just high level. I want to give example to understand better. Okay. This is not how I know. I'm not expecting you to understand this from this theory, but I'll tell you what they actually mean with examples. Now, authoritative server, what that does is, okay, we talked about this thing called SOA, which is start of authority, right? As well as what zones do, right? It has all of these records, right? Now, authoritative server is essentially that itself, which is it holds everything regarding a zone, that is all the records and whatnot, so that it can answer anything regarding the zone. That's it. In that zone, what does that mean? In that domain, if I have staging.devoid.org or staging other various subdomains in the whole ecosystem of things, this authoritative server will be able to point me exactly that you need to go here or there, right? For example, I'll give a full example with the dig. That's better than giving like small examples. But that is what authoritative servers are, recursive resolvers are, and stub resolvers are. Stub, simple question, simple answer. Recursive, I ask a question, like for example, the questions will be like, where is DevVoid.org? That's it, right? That's the question here. And the answer will be yes or no kind of thing from stub. If it has it, it'll give it. If it doesn't have it, well, it doesn't have it, that's all. But a recursive resolver will go and check all of its data to try and get that answer for you. It's going to try its hardest to get that answer for you. And authoritative server is going to be like, If it is part of my domain, I will definitely find it for you. Otherwise, I'm sorry, I don't have it. That's what authoritative server is. It's very specific, very fixed on what it does. That's all. So resolvers and servers to a certain degree, that's what it does. Now we will see an actual example to understand like how to see the flow and how these come into existence. Let's take you as one of the entities here. Okay, you will search for, let's say, google.com. Okay, if I do that, you will message something called the resolver. Okay, resolver as in the DNS warrior, right? So you do like this and you'll ask google.com question mark. Okay, you will also, this is natively by default, you do recursion. Okay, and RD stands for recursive desired, which means do recursive resolver kind of behavior, not simple stub behavior. Okay, so you will ask the resolver. That's what happens when you do through dig over there, right? Dig command, and what it says is you'll give a request saying where is google.com. Okay, the resolver will always go to the, in the tree, where does it go first? Root. This is what's there in the resolver. The resolver will go to the root. It goes to the root and says, are you google.com? www.google.com. And the root says, well, I am not that, but I noticed you have a .com there. So can you check with that? So it will tell, not me, but check .com. And it will point towards .com because that is connected to the root. Right? Com is connected to the root here, correct? That's all it knows. It doesn't know more than that. So root will tell go to .com. And then the resolver from here says, hey, .com, are you www.google.com? And well, it says, actually, no, I'm not, but I know Google because it's there in my list of addresses. So can you check that out? And it says, I don't know. Sorry, it's not me or not me. Check the ns.google.com. Let's say. Okay. Now, for the simple understanding, NS is the name server, so it's actually google.com only, but this should be there somewhere. So its server is the ns.google.com. We'll just, for understanding, we'll just keep google.com. Okay. Now, the resolver now again asks google.com or the name server responsible for google.com. And this says, yeah, I know where it is, but it needs to be www.google.com, right? But it's there in the list of addresses because an authoritative server has everything within it. So google.com will say, yes, I have it. And here, and this IP contains www.google.com. Okay. And finally, after all this process, the resolver comes back to you and says, here you go, and passes the IP address to you. Now, there is a lot more layers to this, as Puneet mentioned again, which is the router and other hops come into picture. But this is just the DNS aspect I'm talking about. So there's more layers to it. So it only adds more hops to this whole system. And you can already see there's like so much back and forth calls happening. And this happens in like a milliseconds, right? It's crazy if you think about it. How this is happening in various geographic locations and everything happens in like millisecond ranges. Crazy, right? But that's actually what's happening here when you try to search for www.google.com, right? So that's very important to understand here. But yeah, I think in this hops, anything you want to ask or anything till now you want to ask, I think I'll stop there a bit if anyone wants to ask anything. Okay. So I guess finally, I think one more thing to keep in mind is this is when you have a no caching involved. Okay. If caching is involved, right, it can stop at any point here and just give the answers. And this root, the .com, the google.com, all of these levels will have a cache, and essentially it'll lower the whole response time by a lot more. It'll have a TTL as well, like 3600 seconds usually, or some other values. But sorry, it counts down inside the resolver. Okay, it's not in the .com and whatnot. It's happening within the resolver, and this .com and stuff is within the resolver itself. But yeah, so that is just quick things about caching and how the routing happens. Finally, I'll just give quick little examples here. This is all something I was testing with that time, but we'll play around with it a little bit more. Okay. For example, if I do dig google.com, you can see I get only this much. We can't see the hops and stuff happening, right? To see that, we'll do dig plus trace at this one, and here you can see a lot of things happening. I got so much data, but let's just summarize it. Let's not try to read it detail right now, but you can see this is the root server first, correct? What happens right after I do google.com? If I want to trace it one by one, it actually tries and goes through the root servers and asks for, can I find the next step? And this thing says .com is the next step. Then it finds the top level domain, TLD servers, which tries to find com. You see com dot. Right. First it tried to find dot here, right? Then it tried to find com dot. With multiple servers, not one server, there's multiple top level domain servers. After that, it goes a little bit lower and goes to google.com, because the last one here said that, hey, this is where it is, check it out. And that's where it goes and checks this. Now, even in google.com, there's 4 servers, which is the name server I talked about. So it checks NS1, NS2, NS3, NS4 to find whether this www.google.com is there, which is where it redirects to. And then finally, it gives me the answer. As this is the IP. These are the IPs. So multiple IPs, multiple geographical location, whatnot. But that's the steps here when you do dig. And when you do basic, this is not through browser, this is just through checking through DNS levels, right? So those are exactly what I told in a representation. I want to do more about this and whatnot, but I think it's already, I just realized how long this has been going for. So I want to keep it a little bit short now and close it off here. But next time I want to talk a little bit more in detail about dig and how to actually understand all of this, because the goal is you need to understand all the hops and the routing aspects here so that you can really play around with latency a lot, right? How did something that takes this many servers right now, if you guys have taken a look at the network logs and stuff of our current servers, right, when we do development, like that's in one location and we still don't get this kind of performance sometimes, right? Just crazy if you think about it, right? So how did something that's going between multiple servers, multiple different levels and locations achieve a latency of a couple of milliseconds, right? So that's something to keep in mind. I think after 4 hops, everything being within like 1 second is crazy. 4 different servers in multiple, it's not even 4 different, it's more than 4 servers, right? But yeah, so those are actual like crazy stuff happening over here in the background, right? And how big that architecture is to allow this to happen in this seamless manner. There's a lot of aspects to this. I really want to dig deeper into it, but first I want to cover some surface level areas before I dig deeper into any specific areas. So yeah, this is the other aspect, which is routing, covered for this session. So that's pretty much it. I think I will, if anyone wants to ask anything or suggest something or any kind of feedback or anything, like this is probably a topic that you are interested to look into more. Anything on that regards or any questions, just let me know and you can ask.
Yeah, Anish. So one thing is like this whole hop that happened using dig. So you mentioned in your command @1.1.1.1,
Mhm.
right?
Correct.
So that part actually like if we are typing that, I think we are asking dig to go to this server directly, right?
Yeah, which is why I said I skipped some aspects of the router and
Right.
whatnot. I
Yeah.
want to
So
dig deeper into that as a
I,
separate
I
session. But yeah.
in the next session, I think one small thing that you can start off with is like no, like I mentioned, like these DNS queries do get cached in your OS
Correct.
as well.
Correct.
So just the high level overview of that process, maybe not even the like the how it's cached or where it's cached, but like the positioning of things. Like let's suppose we just simply type google.com in our browser. So if it is cached, will all these 4 or 5 hops happen or not between these, let's say 10-15 servers? Is this going to happen or not? Will the resolvers get hit or not in my local machine or in the DNS queries of the browser or some sorry browser I'm saying the router, and in case it's not found over there, then like where does it go next? Like the just the whole level, like a flow diagram kind of a thing.
Got it.
That could be something that from where we can then start diving deeper into things. So it would make more sense for everybody as well as me.
I'll note it down. I already noted it down actually, but
Yeah.
I'll make sure I add that in the next session.
Right.
Mm.
Sure.
Anything else? Okay, I guess then that's pretty much it then for this session. I will close this off then. Take care, everyone.
Yeah. Take care. Bye bye.
Okay. Okay.
Yeah. Bye bye.
Yeah. Okay. Bye bye.
Bye bye.